What's up, guys? So in this video we are going to talk about what is the difference between the crystalline solid and the amorphous solid. So let's go. What is solid? Solid is one of the four fundamental states of matter. The molecules in a solid are closely packed together and contain the least amount of kinetic energy. A solid is characterized by structural rigidity and resistance to a force applied to the surface. Do you know that there are two main categories of solid? They are crystalline solid and amorphous solid. Crystalline solid have a definite shape with orderly arranged ions, molecules, or atoms in a three-dimensional pattern, often termed crystal lattice. On the other hand, amorphous solid. Amorphous means shapeless. This word is derived from Greek. It has irregular arrangement of solid particles. The intermolecular forces are not equal. Also, the distance between particles varies. An example of crystalline solid is salt and diamond, whereas the example of the amorphous solid is glass. If we get a crystalline solid, they depict a clear cleavage with surfaces intersecting at angles that are the characteristics of the crystal. On the other hand, if we got an amorphous solid, it have a disordered array of components not showing a definite shape. When cut, they show irregular shapes, usually with curved surfaces. Here's an example. If we cut a table saw, they will form a cleavage form or a even surfaces. As you can describe here in the picture, they still form a cube figure. Like if we break or cut a glass, they will not form any cleavage form. Instead, their surfaces are uneven, as you can see here in the picture. The melting points of crystalline and amorphous solid. Amorphous solids do not have definite melting points, but melt over a wide range of temperature because of the irregular shape. On the other hand, crystalline solids have a sharp melting point because all the components of atoms, molecules, or ions are the same distance from the same number and type of neighbors. That is, the regularity of the crystalline lattice creates local environment that are the same. Crystalline solid. Crystalline solids possess different electrical conductivity, thermal conductivity, refractive index, and mechanical strength within a crystal in different directions. Hence, they are called anisotropic. Amorphous solid. Amorphous are called isotropic because of similar physical properties from either direction. Here is the diagram of the differences of the amorphous and crystalline solid. Crystalline solid have an ordered structure, have a sharp melting point, have a definite heat of fusion, anisotropic since their physical properties are different in different directions, have a covalent bands, ionic bands, van der Waals band, and metallic bands. Amorphous solid don't have an ordered structure, don't have a sharp melting point, have no characteristic heat of fusion, isotropic since they have the same physical properties in all directions, have covalently bonded networks. So that's all for this video. Thank you for watching.